My name is Ron Shapiro. I'm the VP and CTO at Qvera. Qvera is an interface engine company. And this presentation will go over a demonstration application that we presented at the last HIMSS conference. And in this demonstration, we were able to extract data from the Apple Health Kit, turn it into a FHIR resource, submit it securely over a web service call, and aggregate it into a patient's chart in an EMR. We did all of that in the iOS 11.3, which doesn't have the new FHIR capabilities that Apple just presented in the last hour. This kind of gives an overview of the workflow that is involved here. A patient would use some type of a wearable device to gather their heart rate and blood pressure. Via Bluetooth, it would be synced to their iOS device. And then we wrote an application, which I'm going to show. And this demonstration will be more demos and in code than a presentation. But, and so I'll be showing that application that will actually extract that health data, the blood pressure and heart rate data, out of the Apple Health Kit on your iPhone and assemble it into FHIR resources and then submit it securely in a bundle to a secure endpoint hosted in the Qvera interface engine, which once we have the data in the integration engine, then you can do with it whatever you need. And in this case, we injected it into the patient's chart in the EMR. The wearable device that, or the device that we used was an Omron Bluetooth-enabled blood pressure device on your wrist. You put the Omron on your wrist, press the start button. It takes a blood pressure reading, and then automatically syncs it to your iPhone once you've paired those two devices. So the overall goals of the demonstration are to access the health kit data, assemble the data into FHIR resources, send it securely to a web service, and then populate the patient's chart with the data. So let me just demonstrate how that worked, and then we can go into a little bit of detail on how we accomplished that. So I don't have the Omron device, but we can mimic gathering some blood pressure data in the application. We built just a demonstration app that gathers the heart rate data and blood pressure. And so if I click the Get Latest Blood Pressure, you can see in the log window that we go out and we get the latest values from the Apple Health Kit. And to show that, I can come over here and bring up the Health app and navigate to the heart rate. And if I go to the current week, the last readings were 72 and 86 yesterday. And then if I also look at the blood pressure, the last reading was 129 over 89. So now we can go back to our app, and we can simulate gathering a new blood pressure just by manipulating the slider. So if we pull this down to 110 over 70, and let's say we're a little more calm now. When we press this send to the Qvera integration engine aggregator, it will actually post that latest blood pressure reading that you're seeing here on the demo screen back to the Apple Health Kit. In addition to that, it will also pull all of the blood pressure readings stored in the Apple Health Kit, assemble them into FHIR resources, and send them to the integration engine. So when I press this send to the QIE aggregator button, we've now done that. So it's posted securely to the local host listening endpoint, and it's also updated that in the Apple Health Kit, which we can show by coming over to the Health app now. And if we go to today's date, we now have our 110 over 70 blood pressure. And if we do likewise for the heart, if we come to today, we have the 70 heart rate. Now let's look at what that looks like over in the integration engine side. if we come into the channel here and look at what we received, we can see that on the 20th today we received a message. This was a secure HTTP post. So there's the post. And then we extracted the bundle of FHIR resources that were sent over. And so here are those. And I probably should use a bigger font so you can see it. So the first resource is an observation containing blood pressure, systolic and diastolic. And if we come down here, we can see that we've got the 110 systolic and the 70 diastolic blood pressures included in this resource. Now, it is a bundle of resources, so we can collapse these other older observations down and come down here and find the heart rate as well. So here's the observation for the heart rate at 70 beats per minute taken on the 20th, which is today. So there's an example of how those FHIR resources came over. So how did we get from the Apple Health Kit to a FHIR resource that was able to be sent across? And that's kind of what we wanted to show a little bit of in this demonstration as well. But to get there, let me resume this. And let's talk about first, how do we access the Health Kit data? We use the Health Kit development API includes a rich library of APIs that you can use to access all of the data in that Apple Health app. And in this case, we're using the HK sample query. Oops. To learn more about the API, the developer.apple.com has complete documentation, or you could just Google, Apple HK sample query, and you can get straight to the documentation for that query and with examples on how to use it. In this case, we're calling the HK. We're initializing with a sample type of blood pressure, so we want to get the blood pressures. We have no predicates, no limits, and we want to sort by the time sort. So we want the most recent blood pressure first, and then we take those blood pressures, observations, and we gather them into an array of the values. We're going to use that array in the next step when we actually convert it into a FHIR resource. So the way we did that to convert it to a FHIR resource is we simply popped out to the STU3 spec, and we came down to the observation resource. We hopped over to the examples. We grabbed the blood pressure measurement JSON example, and then we copied and pasted this resource over into a file that we created in our AppleKit project. So if we come over here, this is that resource that we've kind of trimmed down and cleaned up a little bit straight from the FHIR spec. Then we injected in some little placeholders for the ID, the systolic pressure, and the diastolic pressure. So then to create to convert the actual data into FHIR resources, we simply used a string with format where we pass in that blood pressure text as the template, and then inject in a new UUID for the ID, the date that the observation was made, and then the values for the systolic and diastolic pressure. Follow a similar pattern for the heart rate, and you've now created an observation for your blood pressure and an observation for your heart rate. Then how do we get those sent securely? You use the AppleKit API call for calling a web service or uploading with an HTTP request. And in this case, it's a secure endpoint, so it uses HTTPS. And we basically just post that payload, which is the FHIR bundle, a JSON FHIR bundle, to the endpoint. So let me dive in a little bit more about what you do with that bundle once it gets there. In the integration engine, we can take this message that we sent and walk it through. And so when the request comes in, it's formatted into an XML format. And then we are able to extract the payload out of that. The payload would be the content in the C data. And it's actual these JSON formatted FHIR resources gathered together into a bundle. And so the integration engine takes that JSON bundle and then it stores it so that it can later be used to extract those values and inject them into the patient's chart. With the integration engine, though, we can do some other interesting things. For example, we can get quickly, with one line of code, we can find out, well, how many entries are in this bundle. So we get the JSON array count of the number of entries, and then we can log that out. And so it shows that we have 18 vital signs in that bundle that were sent across the wire. Another interesting thing we can do is we can extract the latest blood pressure. And so if we're using the JSON model, then we can use kind of a pseudo JSON path to find the value for the systolic and the diastolic and log that out. And so in this case, we can see that it was logged out at 110/70, which was our latest. And then another interesting thing that we can do with the integration engine is we can also convert that JSON FHIR bundle to XML with one line of code. So, and then we can, instead of using JSON path, we can use XPath. And this allows us to ensure, and then you can use XPath where you're actually ensuring that the first component encoding is the systolic, and then you use the LOINC code for the diastolic. And if we look at the results of that one, it also shows that it did find the 110/70. So, and then the last step would be to inject that data into the patient's chart. And you could do that either via a web service, or in this case, we also just extracted out, identified the patient, the systolic, diastolic, and heart rate, and used a SQL query, parameterized query, to inject those into that patient's chart using the open EMR. So in summary, the health kit data is easily accessed via the Apple API. In the newer version of iOS, which will come out this fall, which they already have available for developers to download, in the presentation that they just did last hour, they showed how you can actually get the FHIR resources. Those FHIR resources, though, are based on DSTU2 because it's based on the Argonaut project. I've shown you here how you can do any version of FHIR and assemble the FHIR resources that way using a template. And then we also showed how the FHIR bundle can be sent to a secure web service via the Apple API calls. And then you could take that data once you've got it and assemble it, inject it into the patient's chart via HL7 version 2 message, maybe a web service call, or direct SQL, whatever the EMR would support. If you'd like to read a little bit more and learn a little bit more about this demonstration that we did, you could go to this URL, the HIMSS 18 set iOS health data FHIR, shapiro@qvera.com. And as always, you could email any questions to me at rshapiro@qvera.com. So with that, I think I finished a couple minutes early. So if anybody has a couple of questions, so I could field one or two and then turn it over to the Asymmetrik guys. Thank you.
My name is Bryan Young, and I work with a company called Asymmetrik with my colleague Andrew here and some other folks in the room. We are a company based out of Maryland, just outside of Washington, D.C., and we specialize in building software for enterprises, for government agencies, and more in healthcare these days. And we focus very much on large-scale software systems, cybersecurity, that sort of thing. And a few months ago, we entered and won the ONC's Secure FHIR Server Challenge. And so we wanted to talk to you today a little bit about what we built, some of the issues that we faced, and maybe leave some best practices around security. As you see here, the server that we built is based in Node.js, and so it's on the JavaScript stack. It is modular, and the idea there is we want to be able to let you connect to any data source and FHIR enable it, and it's secure by design. And so, Andrew, if you want to. And so what we're talking about today, when we went and started to build this server, we looked around for best practices for what a FHIR server should do around security. And we have to say that we didn't find a lot. If you look at this page here, best practices for FHIR resource servers, it's not exactly verbose. So I'm going to turn things over to Andrew, and he's going to talk a little bit more about our server and some security practices.
So, transition time. Yeah, so as you may as you may hear, I had some brief encounters with the medical system recently. So if there's a frog involved in helping me deliver the presentation, you know why. So at a developer conference, start with some code. This is actually the only code we have in our presentation, completely unlike the last one. So our goal here was to really sort of make it easy for developers who work for organizations who have a ton of data but might not be in EHR, who already are working on FHIR things, to be able to expose their data through FHIR, to sort of democratize the FHIR ecosystem, be able to just pull in more data from different sources that all might be able to conform to the FHIR spec. So we built it around to be easy to use for a developer, so that you basically don't need to understand all the weird nuances about the FHIR spec in order to be able to put your data up into it. So this is an example of the configuration file for our server. We basically built two pieces: a library of sort of all the core FHIR resources and validators, and then we built a reference implementation that uses Mongo at the back end. But the goal really is that you can use whatever database you want in the back end and build the adapters. So for example, if you're writing your application on the server side, you'd set up some configuration. It looks a lot like an Express configuration or something. You configure the server, give it SSL keys. You set up where you want your audit logs to go. I'll talk about that a little bit more later. You define the profiles and which versions of FHIR you want to support, which you can actually support different versions for different profiles. In this case, the profile is really just a class that implements a bunch of methods to get the number of resources of that type or search for in various ways. And that basically gets all the search parameters that were passed in and some Express things as well, because we're using Express in the back. And you connect the pieces together, and you have a server. I'll talk this way. All right, so really our goal of what the FHIR library is to automate conformance statements, to validate all the payloads coming in and all the payloads going out, be able to run conformance tests against that, really with the goal of having the data trusted. So data coming in, whatever database application you're running behind it can trust that that data is actually correct and conforms to the FHIR spec. And any client applications that you're building on the front end can trust that the data coming back out of your system is conformant and complies with the FHIR spec. So let's talk about some lessons learned that we encountered during this process. We basically started this in December, and we're jumping in and had to learn a lot really fast. So First of all, you all know that FHIR is really, really big. It has a ton of resources. It's also updated pretty frequently. And we're a software development company. We have paid clients. We're doing this as an open source project. We don't have weeks of interns' time to go and update all the validators all the time. So the approach that we took was basically to build out a library of self-writing code. So we're using the JSON schemas that are published as part of the FHIR spec for each of the versions. And we wrote some parsers around that are able to assemble the validation code. And for whatever version you run them against. We actually are also generating unit tests because meta-meta programming is fun, based on that same thing. And we encountered some issues with that. Basically, what we found is that the JSON schemas are not actually complete in the way we would want them to be. So there are a bunch of things that are missing. For example, here's a language definition. It is very precisely defined as being 2 or 4 characters with a hyphen from this coding system, and that's all we get. So turning this into an actual spec that we can, like regular expressions or validations based on that, can't really be done. We could build out some sort of natural language thing, extract out what the ISO codes are, and then they change the format of that text and our validator breaks again, or our ingest breaks. So there are gaps like that. Also, we found search parameters are very precisely defined in the FHIR spec. So all the different ways you can chain them together, and greater than, less than, and which parameters are defined for each resource. But it's not actually part of the JSON schemas, and we couldn't find in the spec. Perhaps there is somewhere else that we didn't find. But what we looked at, we were not able to find a place where those are actually precisely defined in code. So we ended up with having to run all of our ingests and then manually do a bunch of adjustments. And we think that as a FHIR community, we can come together to actually make this easier, and that if this were easier, it would actually be easier for all of the different people trying to build both FHIR servers and FHIR clients. It would allow for this sort of automation to be a little more straightforward. So I know that we've talked about versions a lot at this conference already, so I might skip through these pretty quickly. But if you're building out a brand new FHIR server or even a FHIR client, which versions should you be supporting? Right now, if you want to be compatible with EHR, it has to be DSTU2. Basically, that's, Argonaut project is basically where things are. Apple Health just did DSTU2. That's a couple years old. R4 will be ready any day now. R4 actually solves some of these version problems. But at the moment, we built things out so that you can basically define which versions you want for each resource. You can define all of the versions if you want that we've implemented. It creates a bunch of different endpoints for it. And our goal is, as part of the server project, to be able to actually translate between versions, so that if I implement a DSTU3 thing, because I'm building it right now, and that's what is robust and mature, so I'm going to build all of my resource adapters to DSTU3, and then a client comes in and wants to speak DSTU4, we'd like to be able to give you that data and do some translation layers. We think that that's possible. Certainly for 3 to 4, it may not be possible for 2 to 3. Hopefully from 4 to 5 or whatever comes next, it will be much easier because of a bunch of things that are now in R4, but will not be backward compatible to 2. So basically what we found was there are a lot of breaking changes between the versions. So fields got renamed, resources went away, came in, so you can't really do a direct mapping between them. At the moment, until R4 comes out, there's no version information actually stored with the records itself. So if you have a mix of different kinds of records in the database at different versions, you can't really tell. You have to store that external from the record because FHIR doesn't really define that. And at the moment, at least, there's no easy way for a client and server to negotiate what versions they support. You have to know this server has an endpoint which is, server / DSTU2 / whatever, or server / STU3, and then you work with that endpoint, but you can't sort of discover which versions are supported on the server. And we're hoping, again, all of these things can be addressed in the future. That will make it a lot easier to build out these kinds of applications. The third thing we found out doing a secure FHIR server is, well, part of security is you have to have OAuth. And setting up OAuth sort of as a standalone thing is not actually easy. We, as part of the ONC challenge, were building out a secure FHIR resource server. And well, what that meant was we actually also needed a secure OAuth server. We tried to use ones that were already online, like Smart Health IT. The Cerner Sandbox actually has a great OAuth server that they've set up a lot of app development things with. But it's pretty closely coupled to their data. So that meant that we weren't actually able to use their server and our FHIR server with our own data in it, even if we were going to map the patient IDs. We, for the contest, stood up a sort of stub OAuth implementation. We're now using the MITRE ID one, and we're probably going to move to a passport one in the future. But basically, for our implementation, or at least for our reference implementation, basically OAuth had to be built in. It's also not super easy to get a commercial one off the shelf, because you have to get patient information in there. You have to define all of your smart scopes and things like that. And there are a couple of different ways that you can pass a token back to OAuth. There's the OpenID way, and there are a few other ways as well. And in addition, the conformance test tools right now basically are just, well, if you're using Smart, paste in your token here, and then we'll just run all the conformance tests. There isn't really a good way to click on something and then go into an OAuth flow. There isn't a good way to log in as a patient. Really, you're logging in as a provider and then saying, here's the patient I want. So again, there's a lot more that we can do here to fix this. So let's move on and talk about security for a bit. We built a secure server. A lot of these security best practices that we're going to talk about now are all common sense, really apply to any web application that you're building at all. We just noticed that really people haven't really said a lot about security at this conference yet. And that's one of the things that we pride ourselves on and figure that it should be shared. And you can never talk about security too often because people always forget things. So first of all, if you're not using SSL, you should be. If you're using SSL 1.0, you should not be. That was deprecated a couple years ago. Security vulnerabilities, use strong keys. So one of the important things that we put in our application was filtering out bad incoming requests. There are lots of things that hackers can do to actually send requests to your server to try to do things to it that they shouldn't. So, for example, things that look like database commands. SQL injection is a fairly common kind of attack. Things that get printed back out to a client that might be JavaScript in their browser that then goes and loads some malicious thing or spyware or something. Buffer overflow attacks are a little harder to explain, but basically just if the data that's coming in is too long to actually be stored in the variable that's going to capture it, and you're not actually properly checking that, there's a way that you can sort of access parts of memory you're not supposed to be able to access. So in our solution, we used Helmet.js, which is an open source project for Node, but every server should definitely be looking at doing these things. Guard against vulnerable packages. Don't just trust that all the other people's code that you're using actually works and is free from vulnerabilities. Part of our build pipeline uses snike.io, which is just sort of, there's a free version that works with GitHub. It gives us this fancy badge on our GitHub page. Every other language that has libraries, though, has tools like this that can sort of analyze for published vulnerabilities. Another major thing we encountered is don't put your logs in the same place as your data. Because your logs are capturing what is happening in your system. If a hacker comes in and compromises your system, you want to know what they're doing and what they have been doing. If your logs are in the same place and the hacker figures out that they're there, they remove all the records of what they did. That's bad. Don't let that happen. So store basically all of your logging information in a different cluster. We made it easy sort of in the config thing. We have a logging framework. You can write them out wherever you want to. Also, system logs, things like error messages, don't necessarily have to have patient information in them. If they don't, that's totally fine to store them in a less secure place that's not like HIPAA compliant. It should still be secure, but not necessarily HIPAA compliant. If that's true, though, make sure you're scrubbing out secrets and everything else from those logs. So let's talk about OAuth for a bit. One thing we discovered was OAuth lets you send scopes and patient IDs and everything else directly in the token that's coming into your server. However, under certain circumstances, it's actually possible to spoof those tokens, sort of change your scopes, re-sign it, and send what looks like a valid token that has scopes that the patient shouldn't actually have. So to guard against that, you can send the token back to the server or send an incomplete token. So a token that is valid and says this user has authentication, but does not include the scopes. You can send it back to the server. The server will send you back what the scope should be, and then you can work with that. That extra round trip is just more protection that the user is actually authorized to do what they're trying to do. The challenge with that is that not every OAuth server actually is required to implement that. They don't all have to implement it the same way. We built our solution around the well-known endpoint part of OpenID, which seems like that's the direction that the Smart on FHIR team is generally moving. So it may be that that is the only sort of official one in the future. This one, follow the Smart Health IT best practices, define scopes on all of your endpoints that people can potentially access. You may have public ones as well, like, for example, doctor scheduling you might not need to log into. But anything that has any kind of patient data, make sure that you're scoping properly. Also, at the moment, the scopes are really only at the resource type level and then what kind of CRUD operations you have. So like observation read, right? You may, for your application, actually have things where you want the patient to be able to read certain kinds of observations, but not other kinds. Smart Health, or like the Smart on FHIR spec does not really provide a mechanism to do that. You may want to include that in your own implementation. Part of our solution is we pass the user object in as part of the express request so that when you're implementing your function, you can apply additional fine-grained control if you need to. So here's an interesting one. What should happen if a patient visits the patient search endpoint? So we did a lot of research on this problem. The Smart on FHIR spec does not actually say what the scope should be on that. Obviously, you can just prevent patients from doing that entirely. Just say that providers have access to the patient search, but patients themselves don't. However, you could give them access to it. We argue that that should always return one record, which is the patient's record, or 0 records, which is what the search you did does not match your own record. If you do anything else, like for example, if you give back 403 forbidden errors, if the search returned results that the patient shouldn't see, then a clever hacker can actually figure out a combination of search parameters to use to start to figure out who the patients might be. That by being able to tease apart, well, I know what my record looks like, who else might be in here? So don't let that happen. Don't expose existence of records. That's actually the same thing about don't show people what, if they're putting in a username password, don't show them that their username was successful but their password wasn't, right? Because then they're like, oh, well, that's a valid username. I can keep hacking that. So same principle applies here. So lastly, make sure you're running your tests against the unhappy paths. We've talked a lot about conformance tests and about making sure that all of your data is compliant with what the FHIR spec is. Well, what if it's not? What if the request coming in is not compliant or has errors in it or is trying to manipulate data in some way it's not supposed to? What if a user is trying to gain unauthorized access, right? Like all the testing tools that we were looking at for conformance testing, you put in a token and then it runs and it's like, oh, I was able to get the patient because I have a token that lets me do that. Well, what if your token says you're not able to get that patient? There aren't really a lot of tests for that right now. So look at that as you're building out your solutions. So that's just a summary of these various things. We can work together as a FHIR community to address all these things and make everybody's solutions better. So links to our open source project. We also have a song. Look up We Didn't Start the FHIR on SoundCloud. And I think we've got maybe 1 or 2 minutes. So, yes. Yeah. So we're still sort of building out demonstration code. We don't have any actual use cases going through our system yet. Maybe ask us in 6 months. But we've generally been using the mean2 stack, Node and Express for a long time, and we found that passing in user objects lets you do a lot of things on them based on what groups they have or roles or things like that. So that's at least what we had in mind for that, for the part that we built. Yes?
Related to your slide about defining the existence of records.
Yes.
So
I honestly don't know the answer to that. There's definitely a process for requesting the specs be changed. There are a bunch of people who are spec writers at this conference. That's definitely a thing we should talk about. And I don't know what the expected status codes are for search. It's sort of one of these things where, well, you should always be able to search, and just what you get back might vary depending on your permissions. That hasn't really seemed like it's very well defined. Partly it's governed by FHIR, partly it's governed by SMART. There's sort of this gap around who should have permission to do what. That seems like the EHR vendors are putting in scopes in all the things that they're doing. I don't know if they're making them up or if they're following some practice. And if people in the room do know the answer to that, let us know, definitely.
I think some of them are using 403.
Right. To deny access to the endpoint entirely. Yeah, I mean, that's what you should generally be doing if a user is unauthorized, to access that entirely. But what if they're authorized for a piece and not authorized for a different piece? I don't know the answer to that.
The code that you use to validate JSON schemas.
Yes. So we are checking that code into GitHub. We are planning to, at some point, split those out into different repos for each version, so you can only pull in the ones you care about. We are trying to keep our framework pretty lightweight. We haven't done that yet. Right now, it's all in the repo. So, all right. Great. Thanks, everyone. Come talk to us if you have more questions.